h approaches 0 of, where is it? Ba-dum, ba-dum, ba-dum. Oh, sorry, yeah, that's what I was going at. As h approaches 0 of f of a plus h minus f of a all over h. Notice that h is that distance right there. I could think about it as just h, or I could think about it as a plus h minus a. H's go away, give me the h. Alright, so I'm going to go ahead and use this one. This is the derivative at a point. It's similar to our first example on the previous video. So this is f prime of a. And then this one over on the left, do I have any space, is f prime of x. And I'll show you an example where I do one of those in a moment. So what I'm going to do is use that first definition. So let me go back to it. Oops. I'm going to use this blue definition right here to find the derivative of this thing at 3. So I'm looking at the limit. Actually, I'm looking for f prime of 3, and that's equal to the limit as h approaches 0, fraction bar. I get an h in the bottom. And then I have f of my value, 3, plus h minus f of 3. You should see, I'll flip back, that's the same form. My a value is the 3. And then I've got the h, and then minus the f of a. So if I flip forward, you can see that that a shows up here, and the h shows up here and here. A here and here, h here and here. All it is a difference quotient. It is slope. So when I do this, I'm going to plug in. So it's equal to the limit as h approaches 0. And remember, I have to keep my limit notation there all the time. So it is 2 times. So now I'm just going to plug these values, or this value in for x here, and then subtract this value in for x as well. So as I do that, I get 2 times 3 plus h squared plus 10 times 3 plus h. That is this part right here. Maybe I'll change colors. So the next part is going to be this. So minus f of 3. So I'm going to go minus, I'm going to put a little bracket, and then I'm going to go 2 times 3 squared plus 10 times 3. And then that's all going to be over top of h. You may be like, oh my god, but trust me, it will work out very nicely. So this is equal to the limit as h approaches 0 of 2 open parentheses. I need to square that out. When I square it out, I get 9 plus, don't forget your middle term, 6h plus h squared plus 10 times 3 plus 10h, and then minus 2 times 9 is 18, and then minus 30. And you'll see why I left those there as we go through. And I forgot a set of parentheses right there, all over h. Maybe you already see some things that are about to cancel. Remember, I'm finding f prime of 3. So this is equal to the limit as h approaches 0 of 2 times 9 is 18 plus 12h plus some distributing, that was the 12h, plus 2h squared, 30, 10h, blah, blah, blah. So plus 30 plus 10h minus 18 minus 30, all over h. So what I want you to notice is that I got an 18 here, that's positive, and a minus 18. So they cancel. Similarly, I've got a plus 30 and a minus 30. They go away. If I've done my work right, then things like this should happen. I'm going to collect my terms. You should see I had a 12h and a 10h. They made 22. 2h squared came with 2h squared. And I got this guy on the bottom. So you should see that I have some h's that cancel. This guy is going to cancel with this and one of these. So that's now going to just be a power of 1. So my almost last line is the limit as h approaches 0 of 22 plus 2h. Now, notice, all along I could not plug in h equal to 0 because I had that h in the bottom. Now, just like we've talked about with limits, I've gotten rid of that issue because I've canceled it out. So now I can plug in h equal to 0. So you should see that my final answer is equal to 22. So what that represents is the slope, of whatever this function is at x equal to 3. So I'm going to go over here, and we'll come back to that in a moment. One of my other equations looks very similar. Go back to here. If you remember this thing right here, it was actually very similar to the one that we either talked about in class or the one in the previous video. So I'm going to have another very similar definition of a derivative for any given point that's similar to that h. I'm going to write it out. Oh, sorry, I didn't realize I wasn't paused there. Anyway, you now see that, and you watch me write it and didn't say anything. Anyway, so this is super similar to that previous definition, and you should see that it's another difference quotient. I could draw a picture. So if I had a function, this would be my x value, this would be my x plus h value. My triangle would look like this, and then you can see that I would subtract. This would be f of x plus h right here. This would be f of x, and I get that same difference quotient. Okay, so I'm going to do this with that same function from before that we did over here, but instead of finding it f of 3, or f prime of 3, I'm going to find the actual equation like I've been talking about all along. So, f prime of x is equal to limit as h approaches 0 of, alright, so maybe green. Let's see if I can get a little bit more red. Is that red? Yeah, that's red. So, I'll do that part in green and that part in red. So my green part is going to be 2 times x plus h squared plus 10 times x plus h. That's the whole. That's just plugging in x plus h for f of x. Now I need to subtract this. So I'm going to get minus, and then I'm going to put it in brackets to make sure I take care of my minus signs correctly. 2x squared plus 10x. And that is all going to be over top of h. So let me do some work to write this out. This is going to give me limit as h approaches 0. I'm going to have 2 times x squared plus 2xh, that's the middle term, plus h squared plus 10x plus 10h. That's all of this partially FOILed out and this 10 distributed in. And then I'm going to have my minus 2x squared. Need to distribute the minus in here. So minus 10x. That all goes over h. So let's look. I have a plus 10x and minus 10x. They cancel. I don't see, I forgot a parenthesis again. Alright, that's right. Yeah. Don't see anything else that cancels yet. You may already. So, next line. Limit as h approaches 0. I'm now going to distribute this in to those three terms. 2x squared plus 4xh plus 2h squared. Now my next term is actually this guy, then this guy. So plus 10h minus 2x squared. All over h. So, now watch what cancels. I have this guy, this guy. They go away. It's kind of nice. And then look, all the rest of the terms have an h in them. Do you see that? So let me show you. This guy has an h, this guy has h squared, and this guy has an h. So I'm going to rewrite that top like so. This is an h over here. H. I just pulled that h out of each of the terms, and this is what I was left for the rest of them. So as you can see, now these cancel. And I can actually plug in h equal to 0 now that I've canceled. Remember, I've said it over and over again. The whole point of limits is to get that cancellation process and then plug in. Limit as h approaches 0, 4x plus 2h plus 10. That is just 4x plus 10, which is actually my answer. That is the derivative of what was the original function? F of x equal to 2x squared plus 10x. Now, if you remember, went through all that other work to get this 22 over here. So we did some work and we found this equation for the derivative. It better work. Remember that 22 was the value at, what was it? It was f prime of 3. So let's see if we get when we plug in 3 to this thing. Remember here, boom, see, same equation, but now it's just in terms of x. So this thing right here is f prime of x. So let's see what we get for f prime of 3. Well, 4 times 3 is 12. I'm just using this guy. Plus 10 gives me 22. Same answer. And you may be like, oh my god, I can't believe you spent all that time to get the exact same answer as we did in this thing. Well, this took a fair amount of work right here, but notice if I was with this thing, if I had this guy right here, and I suddenly change this to a 6. You'd have to go through all this work all over again, blah, 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 with this and this and this, all 6's, and then it would track through, blah, blah, it would be terrible. But if I wanted f prime of 6 for this, well, now I have an equation for it. Well, 6 times 4 is 24 plus 10, so it would be 34. Boom. That's a lot faster than going through here. So we actually prefer this method right here, using this guy, or one of its other variations, which there's lots of variations, and you've already seen a couple of them. But this or one of its variations are way more useful than finding the derivative of a point. You just need to recognize the derivative of a point. So that's all Hopefully you've made it to the end of this video.